Okay, let's look at one last example. Let's try to find a power series representation of the function tan inverse of x, which we know to be the integral of 1 over 1 plus x squared. And let's try to use our answer to calculate the sum of this very complicated looking series. Well, 1 over 1 minus x is the sum of the geometric series, the sum of x to the n, on the interval from minus 1 to 1. Substituting minus x squared for x, we get 1 over 1 plus x squared is the sum from n equals 0 to infinity of minus 1 to the n x to the 2n. And this is 1 minus x squared plus x to the 4 minus x to the 6, etc., etc. And this works for x values between minus 1 and 1. And now we can integrate to find a power series representation of tan inverse. So integrating that equation on the left, we get tan inverse, and on the right we get c plus the sum from 0 to infinity of the integral of the nth term, which is minus 1 to the n x to the 2n plus 1 over 2n plus 1. So this expands as some constant plus x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7 for values of x between minus 1 and 1. And this is an alternating series for any x value between minus 1 and 1. Now, of course, we have to find this constant because tan inverse is a specific function of x, so we need a specific function of x on the right. So plugging in x equals 0 on both sides of the equation, we get tan inverse of 0 equals c plus 0, and tan inverse of 0 is 0, so we must have the value of our constant c is 0. So tan inverse of x equals the sum of this alternating series, the sum of minus 1 to the n x to the 2n plus 1 over 2n plus 1 for values of x between minus 1 and 1. In particular, for x equals 1 over the square root of 3, which is between minus 1 and 1, we get tan inverse of x, tan inverse of 1 over the square root of 3, is the sum of minus 1 to the n times 1 over the square root of 3 to the 2n plus 1 times 2n plus 1. And of course, tan inverse of 1 over the square root of 3 is pi over 6, so we get pi over 6 is the sum of this very complicated looking series.